So this video will go over worksheet number 3 for the force practice problems, and the problems will be 1, 2, 3, 4, and 5, 15, and 16. So here we're going to take 22 times 6, which is going to give us 132 newtons. If we've got a 70 kilogram mass being pulled by 140 newtons, 140 equals 70A, that's going to give us an A of 2 meters per second squared. We're talking about weight, so remember, if we're looking at weight, we're talking about force of gravity, which is going to be the mass, times the acceleration due to gravity, which is going to be 10, so 1,000 newtons. What force is necessary to hold a 50 kilogram mass over their head? Well, if I'm going to hold it over my head and just hold it there without moving it, that means that I need to support its weight. So if I'm supporting its weight, it's going to be F of G equals 50 times 10, or 500 newtons. How much force is required to accelerate a 10 kilogram mass upward with a rate of 5 meters per second squared? So I now not only need to hold that 10 kilogram mass above my head, but I need to then move it up. So I need to account for gravity, its weight, as well as the rate of acceleration. So that force is going to equal the mass times the rate of acceleration plus the rate that I wanted to, the rate of acceleration due to gravity plus the rate I actually want to accelerate the object. That'll come to a total of 150 newtons. If we break this down, it would be the 10 kilograms times 10 meters per second squared for the force due to gravity, and the 10 kilograms times 5 meters per second squared for how quickly I wanted to accelerate, which brings us to a total of 150. Last two problems, 15 and 16. So we're looking at this 20 kilogram block here. It's being pulled down by the force of gravity acting on this 10 kilogram block. F of G is going to be 10 times 10, which is 100 newtons. 100 newtons will be pulling through the string on this block. 100 divided by 20, 5 meters per second squared. We're finding the mass of this block if this thing accelerates at 4.9 meters per second squared. So if this accelerates at 4.9 meters per second squared, that's going to generate a force of 49 newtons. So we have 49 newtons is equal to the acceleration. This says that both blocks accelerate at 4.9, so I guess the acceleration is going to be 4.9 times the mass. Divide both sides by 4.9, 4.9, and we're going to come up with a mass of 10 kilograms. Now, here's the thing. The only reason that both blocks would accelerate at 4.9 meters per second squared is if there was some amount of friction between here. Otherwise, this one accelerating at 4.9 meters per second squared would be because this thing is accelerating at 10 meters per second squared due to gravity. So if that were the case, and we were not saying that both accelerated at 4.9, but that the top one accelerated at 4.9, then we would have 49 newtons pulling on this bottom one at 10 meters per second squared times its mass, which would mean that its mass would equal 4.9 kilograms. So if we change the scenario of the question, the answer would be 4.9. If we keep it as it's written, with both blocks moving at 4.9, then the mass of the lower one would also be 10 kg.